Please make these two corrections to your notes. So you're going to add each year right after fairing, and in this parenthesis 2.5. So in example 1 here, two graphs representing how Jared's investment is faring each year in two separate accounts. So you've got account F, which is this blue line doing that, and then account G, which is this red line doing that. Write a function for F. Okay, so if I look at function F, I follow it. I got a point right here, and I got another point right here, and I got another point right here. So if I'm doing coordinates, how can I write a function given coordinates? I can make it a table. So all I have to do is write my coordinates, x and y, x and y, x and y. Okay, so if I give you coordinates, you can make it a table, and then you can find out what that function is. So I'm just going to type everything in. All right, I clicked flag. It needs to go through all my points. So if I zoom fit this, is it linear? It is not. I do know that this is exponential, but I'm going to check quadratic. So I check quadratic. Sometimes with quadratic and exponential, they look the same. You just need more coordinates. But because I know that these are exponential, because I'm in the exponential one, I'm just going to ignore the quadratic one. So again, you do need more points than this in order to know if it's exponential or quadratic in the calculator. But I can see right here that I'm dealing with exponential functions. All right, so go to exponential, zoom fit so that I can see there's my exponential function. All right, and then here is my ABX. So we're going to go ahead and copy that down. So make sure that when you're copying this in, that you're using what they tell you. In this case, it's not X, but it's T. You can write this as a decimal or as a fraction, whichever way is fine. So from a decimal to a fraction, you put the decimal in the calculator, click the fraction, and you can see what it is. All right, which function is increasing faster and how do you know? So again, the steeper the slide, right, the faster it's increasing. Or you can look at it as whichever one's closest to the y-axis as it gets really, really big is the one that's the steepest, because you can see that this one comes down really quick, whereas this one is a little bit more gradual. So which function is increasing faster? The one closest to the y-axis or the steeper one, which is g. I'm going to label it g of t just because there's a t on the f1. All right, so how do I know? And you can put both one of those reasons. So the slide is steeper, or you can say closer to the y-axis. I'll take either one of those reasons. Which function began with more in the account? So what does that mean? That's my y-intercept. All right, so here's my y-intercept for f, and here's my y-intercept for g. Which one is the greater y-intercept? F. So f of t. So f of t is, and explain that, is higher. Oops, that's not how you spell higher. Higher on the graph at the y-intercept than g. What could a possible b value for g? Because I know what the b value is for f. What could g possibly be? Well, that comes down to, okay, if I know what f is, which is less steep or further away from the y-axis, this one needs to be more steep. Because it's growth, I know that the bigger the number, the steeper the graph. So I know that g has to have a bigger b value than f, and that's what I need to know. So remember, just as a reminder from the previous video, if I'm looking at growth, which I am, right, the bigger b is, the steeper graph. So the bigger b is, the steeper graph. Okay, so if I have f's b is equal to 5/2 or 2.5, right? I know that g needs to be steeper than that. So that means I know that g needs to be bigger than 2.5. So now let's look through the answer choices. I have exactly 2.5. They can't be the same because they're not, one is steeper than the other one, right? So they can't be the same. It cannot be 1 because 1 doesn't change anything. When you multiply something by 1, it stays exactly the same. And either 1 is less than 2.5, so it can't be that. It can't be 2.5 because that's another way of writing 5/2. So it can't be that. So it has to be this one because, again, G is more steeper, which means it's a bigger growth. So I need it to be a bigger growth than what it currently is, which is 2.5. So it only can be G of T, or is the sixth one. All right, what does the intersection of the two graphs mean? All right, so let's take a look at what is the x-axis, what is the y-axis. So the intersection I can see is at 125. So X is, here's two graphs representing Jared's investment in each year. So X is time, and investment is dollar, investment. All right, so I got time and investment. The numbers I have is 1 and 25. I just need to put that in a sentence with Jared, and any sentence is going to be fine. After 1 year, Jared would have $25 no matter which account he used. All right, so in both accounts, he has the same amount of money. You could say that. In 1 year, Jared has $25 in both accounts. It doesn't matter what variation, as long as you're using one, and one as time in years, and then $25, and then you're saying something about both accounts being exactly the same. So after one, I'll do it this way. After 1 year, Jared has $25 in both accounts. Again, any variation of that is fine. All right, so guess what I want you to do? I want you to now do example 2. Let's practice.